Now we're going to move on to Northern Crossing, which is the Fort Worth project. It was submitted into the competition by a developer in Fort Worth. This is called Northern Crossing. The winners in this competition, or this category, were Michael Baker, Dewberry, Craig Design Group, and Brown and Gay. We're not going to go into a whole lot of depth about their presentation today, but you just saw the way we just watched the presentation from half. You can also watch any of the other ones like Jeff was saying. So if you want more detail about this Northern Crossing project, they will be getting these, or we will have electronic copies of the presentation available online, which will have links to go and view these presentations from the competition and all the other presentations as well. But Northern Crossing is a 115-acre site. There's 56 acres of it that are undeveloped currently, and 20 acres that are reserved for wetland mitigation. It's located in the Fossil Creek drainage area, and this project, you can see an existing conditions picture there on the right. What I wanted to do for this one is I talked to Burton Johnson with Michael Baker and just asked him some basic questions about their learning process throughout this project and some of the things that they as a firm and their other team members learned as they went through this process. So just looking at their approach there, he said overall the available land was much larger than what was needed for the project. Even with the parking, we were able to incorporate substantial green space. And so in incorporating that green space, they had a few different land uses within this property. They had industrial, commercial, and some multifamily residential. And so they were able to spread things out enough because the available land was more than they really needed. And so they used the green space in between, not only as a buffer between the different zones, but also as an opportunity to treat stormwater that was coming from the site. So I also asked him about the existing features, because one of the things that Leslie talked about earlier is a big part of LID is not just throwing stormwater BMPs at a project to try and make the water quality a little bit better. It's an entirely different way of thinking about a site. So we want to look at the existing features that are on there to see if we can, first of all, conserve them, and second of all, utilize those existing features. So that was my question to him about Northern Crossing, and he said that the site had previously already been cleared and graded, unfortunately, for a different development that ended up never happening, and so they didn't have a true existing condition to start with. But what they did is they looked at pre-existing condition, at what it was when it was in its natural state. And because of that, you see there at the bottom, they incorporated the restoration of native prairie vegetation. That in one of his explanations was that is the prairie vegetation in these clay soils in North Texas will actually help to open up the soils a little bit. It's also native, so it'll be a little more durable in times of drought that we've had recently. So, like we were talking about earlier, the disciplines involved, this isn't just an engineering thing, it's not just a landscape architecture project. There were civil engineers, stormwater engineers, landscape architects, planners, and architects involved in their project. So it was a very comprehensive approach. So just some of the lessons learned from Baker and the other teams involved. He said LID provides an economical and effective way to develop. And then he talked about a lot about his preconceived notions, and I'll let you can read some more of these quotes later on, but the one I really wanted to point out was the one at the bottom. He said, "A few years ago, I could have described myself as an LID scoffer. While I had started to evolve a bit prior to the competition, working through the actual exercise and conducting the research necessary to support the design and analysis really opened my eyes. It changed my opinion and belief in a big way, and I think this was one of the primary goals of the LID competition." And I would second that to say that it is our hope as we do this, and our hope through the iSWM program as well, that we're not just approaching low impact development as a chore or as a negative thing that just adds another complex component to development, but it's a way to rethink everything. And it's if we can take that movement more as a regional approach, and that's what iSWM gears to do as well, to not just try and band-aid fix our flooding and our water quality problems, but do it on a regional basis. Hopefully we can have some good success. So like I said, check out the Northern Crossing presentation, and you can look at all the other ones online at your convenience. Like Jeff said, Freese and Nichols submitted a design on South Lamar Street, which is a project that Dallas submitted to the competition. It's in just south of downtown Dallas as well, not too far from the Cedars West project. That slide shows you our final proposed design, but I'll go through each one of those components as we go. So South Lamar, the project area as it stood in the competition was a 1 mile stretch of roadway with residential, some historic residential on one side, and then industrial and commercial along the facing the roadway, and then on the south side. And then right on the other side of the industrial is the Trinity River. We'll look at existing conditions. So this is a shot of the existing zoning there on South Lamar. The north side there, you can see the Colonial Hill Historic District. Lamar is the blue line. If you hadn't, you'd probably figured that out already. But there on the south side, you see these green earth metal recycling, aluminum recycling, and then down there on the right side is the historic boarding plant that we also wanted to try and highlight. It's not so sustainable, but it is more of a holistic approach to look at some of the history of the area. But there is a plan for the future for this area, and you can see that whole red polygon there is planned for future commercial development. And then you've also got the tollway will be extended through there, and there will also be some pedestrian trails added through to link Lamar Street to the Trinity Trail system. And so there's a big plan for the future development. There are already a couple of roadway projects going on down there that we're tying into, and now that we're more in the design phase, that we're trying to incorporate our designs into the plans of others as well. So this Lamar project is really, the city of Dallas is really excited about it, because it's not just a roadway reconstruction, but it's more of a gateway to their future zoning and what they're looking to do with this area. And so we really want to make a good solid footprint with this project as they move forward into redevelopment. So here's an aerial shot of Lamar Street, and it's a lot of gray, and that's on purpose to show you that it's a 95-foot right-of-way, and for almost the entire mile it's completely paved across that entire right-of-way, but it's only 4 lanes. So what we plan to do is we really wanted to focus on these site design practices. So really trying to minimize our impervious area, minimize the amount of water that we were going to have to treat in the end. And to do that, we decided we were going to take that. It has a very inconsistent turning lane, or maybe just a painted median. There are no raised medians. So we took that median out altogether, and we do have approval from the city to do that. And we shifted the roadway to the south side of the right-of-way. And by doing that, we were able to open up a big green space on the north side that not only is going to provide room for us to implement LID features or some of these stormwater controls, but it also provides a buffer between the residential area and what is now industrial or will be commercial. And by doing that, we were able to reduce the impervious surface from existing conditions by 24%. So you'll see in a second how that really plays an impact or plays a role in our stormwater. So with that 24% reduction in impervious surface, we now have up to 17% decrease in peak flow in the smaller storms. So we're really getting a good benefit in the peak flow, but also we're not just looking at flooding problems. We're going to look at how to treat the water, the quality of the water that's running off of this site. And so by reducing the impervious area by 24%, we've reduced our water quality volume by 28%, which is a huge savings when you go in to try and implement bioretention or any other controls that you're going to use to treat your stormwater. If you can use these site design practices up front, you're going to save a lot of money in the structural controls that you have to implement. So we went through a little process to figure out what BMPs we wanted to use to treat, because we had to use site design practices were the competition requirements, but we also had to use structural controls to treat the first 1.5 inches for 80% TSS. Now, 80% TSS removal is not It's kind of the bare bones of pollutant removal. And bioretention itself actually does a lot more than remove 80% TSS. It's going to have a lot of biological uptake and remove a lot of other pollutants, like the nutrients, nitrogen, phosphorus, and metals, and that kind of thing. And so what we chose to do, we wanted to make this an aesthetically pleasing area. We wanted to make it more functional than it is now. And we also wanted to try and exceed the competition requirements as best as we could. And so by implementing this bioretention feature, we really thought that we went above and beyond what was asked in the requirements, but it's going to be beneficial, especially with the project's proximity to the Trinity River. It's not going to have a lot of opportunity to be treated past our site. So looking at the hydrology of the area, let's see if I don't have the entire watershed on here. One thing I want to point out is the watershed goes way up to the north. It's about a 190 acre watershed. And so we first started looking at the project going, how the heck are we going to treat 190 acres worth of runoff within a 95-foot right-of-way? And then we quickly realized that we weren't. So what we decided to do is let's just look at the runoff within the right-of-way, what we are redeveloping, what we can feasibly handle, and go from there. And the rest of it, now that we're in the design phase of this project, one thing that we've noticed is the stormwater infrastructure along Lamar Street is really old. And there's a lot of things that have happened that maybe aren't the best suited for stormwater management in the area over the previous years, with developments maybe covering up some outfalls and that kind of thing. So we are actually in the process right now of doing a watershed study from the flooding perspective, and we'll incorporate that into our water quality analysis as well. But you look at, we've got 13.6 acres of runoff to treat in this area, and to do that, we wanted to lay out our site. So I've already showed you the plan view of our proposed roadway with the extra green space on the north and that meandering trail for pedestrians. And then on the south, or on the bottom of the screen, you can see our proposed road cross section. And so we've got this road 4 lanes, super elevated, so everything's draining to one side of the road. And then through curb cuts, all that drainage from the road will go into bioretention areas that are spaced along the roadway as we need them. And we'll get more in depth in that analysis when we get further into design of how many square feet of ponding area we need and that kind of thing to treat using bioretention. One other thing we use, I'll point out, I'm not a roadway engineer, so I'll say this really briefly. We use moisture treated subgrade, or we're suggesting it at this point for the roadway, and that's just another sustainable feature. It doesn't have anything to do with stormwater, but it's something that hopefully, if the geotechnical exploration comes back and and moisture treated subgrade is beneficial, that's another sustainable feature of our site that we're going to hopefully increase the pavement life by about 10 years. So some of the specifics of bioretention, I won't go too much into this, but we had to determine our layout, so the location and configuration. We're not just throwing these things in there wherever we can fit them. We're really looking at the topography of the site. We're trying to mimic natural drainage patterns that aren't really natural anymore, but we're going to do our best. And so what the key here is we want to decentralize drainage. We don't want everything, like Leslie was saying earlier, we don't want to drain that whole mile-long stretch of Lamar Street into one pipe system and it never see any green space at all. So what we want to do is decentralize, use as many little pockets of treatment as we can. We're going to eliminate flooding when we do that. And then we're also going to get a real good benefit in the water quality that's coming off the site. And then obviously you want to ensure that your bioretention is designed correctly so it doesn't exceed the maximum ponding depth or the maximum drain time, or else you'll get stagnant ponds along your roadway with mosquitoes, and nobody's going to want to use that meandering trail. And if you're not familiar with bioretention, you can see on the upper right side there is a cross-section of what it looks like. It's really just a vegetated depression that has a filter media beneath it. So you're going to pond water up to about 6 inches, and you're going to slowly drain that amount, and that's your water quality volume that you're treating. So that first 1.5 inches of runoff will be collected and filtered through That's specially engineered media, and then down to an under drain system. And then anything else past that 1.5 inch will go through an overflow inlet, whether it's a bypass, the bioretention on the roadway to a curb inlet, or an overflow drop inlet, something like that within your system. Like we were mentioning on all the other projects, there's a large amount of collaboration that goes into this, and I don't know anything about any of these plants, and I'm not going to pretend to. So we had one of our landscape architects at Freese. We had him go through a few different resources to select some plantings that are going to be appropriate for these bioretention areas. One of the things you have to watch is make sure they're drought tolerant, because in seasons of drought, you don't want to have a crazy permanent irrigation system going through these things, because that's going to jack your costs up. So if you can get these drought tolerant that are also somewhat inundation tolerant, and there are plenty of lists out there for regional examples of plants that you could use. iSWM has a list, and Lady Bird Johnson has a list down in Austin of different regions in Texas. I had one other thing I was going to say. Oh, with establishment of the vegetation on these, we typically say about 2 years. It really needs to be watched. While the vegetation is establishing, we've got a project out in Rowlett that's going in right now. These are fragile systems at first, but eventually they become self-sustaining. And so if you watch them for a while and really take care of them, they can really become some useful infrastructure for your site. So here's a before shot of south of Lamar Street. Lots of concrete, lots of pollutants coming off there. A lot of trucks because of those recycling plants, so you get even more pollutants from that. And then additionally, you're just going to have a lot of runoff because there's no room for it to infiltrate anywhere. I won't get into where it actually runs off to at this point, but that's another presentation in itself. But here's the after shot, and I didn't draw this either. I'm not this good. We have an actual graphic design guy that made this beautiful rendering, and it's cool to see our design as we took it to go on into a picture like this to show the real transformation that happens from that to that. And so it's not just about stormwater, it's about making things a little more aesthetically pleasing, and really making a holistic approach to your project and thinking about the benefits, not just in the short term, but long term as well. So